Okay, so how many grams of aluminum oxide would be form 12.5 moles of aluminum? Am I echoing? Okay. First off, what is it that we know? What's the information given?
12.5 moles of aluminum burned.
12.5 moles. You guys, your mics, neither one of your mics are picking up real good. If you could like get it closer to your mouth or something, that'd be great.
Okay.
So we're starting off with 12.5 moles of aluminum. What is it asking about?
Aluminum oxide, how many grams?
The grams of aluminum oxide. So we're going to put X because that's what we're looking for, and we're going to put the unit in grams. Notice that they gave us information about aluminum. They're asking us information about aluminum oxide. We're changing from aluminum over to aluminum oxide. We're going from one compound to another compound. That's why I drew that horizontal line there, because that horizontal line means we're changing compounds. In order to do that, you need to use the coefficients. In order to use the coefficients, it has to be in moles. So the end caps here will both say moles. So moles of one to moles of another. To do that, we're going to be using the coefficients in the like chemical reaction. That's the only thing we can possibly use to go from one thing to another. We have to go through the coefficients. That's the whole point of balancing the reactions. Now, that gets us to the moles of aluminum oxide. In order to go from moles to grams, what do I have to use? Think back to what we did with conversions.
A fraction?
What? I couldn't hear you.
I said molar mass.
Molar mass is correct. So from here, how do I figure out the molar mass?
Of aluminum oxide?
Of aluminum oxide, what do I have to do?
You would do 2 times the...
We have 2 aluminums, and we have 3 oxygens. So we have 2 times, what's the number say, 26.9?
Yeah.
Yeah.
And we have 3 oxygen, so it's going to be 3 times oxygen, which was 16. I put in the coefficients with this.
No.
No. We've never done that. Let's not start doing that now. Let's not suddenly change what we've been doing, because that's only going to mess you up. Don't worry about the coefficients until we actually start doing the conversions. So what is 2 times 26.9?
53.96.
53 point what?
96, but I also do it to the hundredths place, so I'm gonna have an extra like decimal place over.
This is fine. So 3 times 16 is what?
48.
48 is correct. What do we do with those two numbers?
Add them.
We add them together. So that becomes 108 grams is equal to 1 mole. Follow that? Is there anybody confused right now?
No.
Okay, so now we need to go, now that we have all the conversion factors we need, we have all the data, we're going to start putting it into our problem. Our starting point here is 12.5 moles. What do we always do with that starting point?
Put it over 1.
Put it over 1, that's right. So 12.5 moles. I'm going to take the time to write out AL, because we're actually changing the compound. So we need to keep track of that change. We have moles of Al on the top. What am I going to put on the bottom of the next fraction?
Moles of Al.
Moles of Al. Whatever's on top needs to be put on the bottom. We are right here in our plan, and we're trying to get to the other side. To do that, we're going to use the coefficients. What's the coefficient of aluminum?
4.
4 is correct. So that will be on the bottom. We're going to aluminum oxide. That means we need the coefficient of that one too. So what's the coefficient of aluminum oxide?
Wait, how'd you get the 4?
The 4 came from the coefficient of aluminum.
Oh, okay.
Got me?
Yeah.
All right. So we're going to the aluminum oxide. I think I wrote over, and that's why people can't answer me.
I have a question.
Yeah.
Okay, so you have the 12.5 moles of Al, and then like the next thing on the bottom, it's 1 mole of Al. Is 1 over that?
Is what?
Would you put a 1 over that? Because the way I keep 4 like sets, even if it's just 1 and 1 and it cancels out anyway. I just don't know like if you're supposed to put a 1 over the 1 mole Al. Because you have the 12.5 moles of Al, and then on this, like on the bottom, next thing, it's 1 mole of Al, so that the moles of Al cancel out. What do you put on top of that?
The bottom shouldn't say 1 mole of Al. This should say 4.
I thought you're not supposed to do the coefficients until the third like bracket thing.
That's if you're starting with grams. This time we're starting with moles, so we can go straight to the coefficients.
Because I've been like adding an extra bracket, but it's been 1 over 1, so it cancels out anyway.
I think that's where you're getting lost. That's why I'm trying to go through this. So like we have moles of Al on the top here.
Mm-hmm.
We have moles of Al on the bottom. That means we're right here in our plan with the moles of Al.
Okay, so there's no need for the extra.
There's no need for that second one that you've been throwing in there.
Okay.
You need to follow your units. Okay, so we're trying to get to Al2O3. What's the coefficient of Al2O3?
2.
2 is correct. So we're going to put 2 moles Al2O3. That's the only time you will ever have something besides a 1 with moles. When you're going from compound to compound, when we're changing compounds. This is the only time it'll be anything besides 1. Okay?
Okay.
All right, so we have moles of Al2O3 on the top now. The Al cancels. If we have moles of Al2O3 on the top, what am I going to put on the bottom of the next one?
Al2O3.
The moles Al2O3. We've already used the coefficients once. We're not going to use them again. So what number goes with moles?
Is it 22.4?
That's for liters, honey.
Oh.
At the conversion factor we have out to the right. 101.8 grams is equal to what?
1 mole.
1 mole. So 1 goes over here on the bottom. We're going to grams, so we're going to put grams on the top. So what do we put on the top?
101.8.
Yep, 101.8 grams. So now our moles of Al2O3 cancel out. So from here, we're going to put it into the calculator. We were asked about grams of this. We're ending up with grams. That's how we know when to stop. So it's going to be 12.5 times 2 divided by 4 times 101.8. Who has an answer for me?
I got 636.25.
That is close enough. My original, I got 637.
Would you like take that though? Because I've
Oh,
always
yeah.
gotten the hundredths place, so
I'm good. I'm
okay.
good. Okay, that was hard. But it's expected to be hard because it's our very first time doing it, right?
Mhm.
Yeah.
All right. Once again, my arrow didn't show up. I'm gonna throw my arrow in there.
I feel like the
This is
grams
number 2.
one are more easier. Like when you have the grams first.
Oh, you like doing the grams first?
Because those were the ones that were on the video primarily, so those were all the examples I had written down. So when I started doing the thing, I just looked for the grams ones and were able to do those ones first. So I didn't know how to do the moles because I was confused about that second bracket thing.
Okay. Hopefully this is getting a little easier for you.
Mm-hmm.
How many moles of oxygen? So where is my X gonna go?
Under oxygen.
So I'm gonna put an X here with the unit moles. Now I needed to react with 7.5 moles of aluminum. Where is that information gonna go?
Under the aluminum, the 4Al.
Okay. So we're going from aluminum to oxygen. They gave us information about aluminum. They're asking us about oxygen. So I'm going to draw a horizontal line there. In order to use that horizontal line, what word goes on top of it?
Coefficient.
Coefficient is correct. Now, in order to use coefficients, what unit does it have to be in?
Moles.
Moles. So the moles are going to be the end caps here. So let's take a look at the information they gave us. We're starting with moles, so there's no conversion there needed. They're asking about moles. So do I need more mass or 22.4 or anything like that?
No.
No, you just need the coefficients. That's right. So what's going to go over 1?
7.5.
7.5 moles of Al go over 1. Right here in our plan, the first line, we're going from moles of Al to moles of oxygen. We're changing compounds. Whenever we change compounds, we have to use those coefficients. So what's the coefficient of aluminum?
4.
So 4 moles of aluminum are going to be on the bottom. Where are we going to?
Moles of oxygen.
Moles of oxygen. So what's the coefficient of oxygen?
3.
So there's going to be 3 moles of oxygen there. The moles of aluminum cancel out because they're on opposite sides. So we're going to use our calculator now. 7.5 times 3 divided by 4. Let's get
I don't know if I did that right.
I got the 5.625.
okay, so you got the 5.6 that I said in the answer.
Mm-hmm.
I'm assuming knowing the answer before you start actually helps you guide.
It was a lot easier.
Awesome. Because otherwise you're like, am I doing it right? I don't know.
Well, there was one question, I think the very first question, where I was 50 off, but I was still in the hundreds of what it was supposed to be, so I didn't know if I messed it up. Probably having the extra bracket, I'm guessing.
Okay. So this one we're going to throw grams back in there again. You got that, Shayla? You good? Shayla, you good?
Yeah.
All right. How many moles of oxygen? What am I going to do with that information?
I'm not sure.
You put an X under oxygen because you're
Put
finding
an
more.
X under oxygen because that's what we're looking for. What's the unit we're looking for?
Moles.
Moles, that's right. So I'm going to put X moles. Are needed to react with 100 grams of aluminum. Where am I going to put that information?
Under the aluminum.
All right, so I'm going to put 100.0 here. Okay, we're changing compounds. We're going from aluminum to oxygen. Draw a horizontal line there indicating that we're changing compounds. What word am I going to write on top of that?
Coefficient.
Coefficients. What are the end caps of the horizontal line always?
Mole.
Moles. All right. So if we're starting off with aluminum, are we starting off with moles of aluminum?
No, it gives
No.
you first.
That means we have an extra step in here where we have to go from grams to moles. How do I go from grams to moles? What do I use? More mass. We have to look at aluminum. Aluminum, I think it says 26.9. That's my molar mass. I did not times that by 4. Don't get in the habit. When you do the molar masses, you only use the little numbers. You don't do the big numbers in front. All right. We are going to moles of oxygen. What's our last unit here?
Mole.
Moles. So that's when we stop. We don't have to do any other conversions. All right, so what's my starting point? What goes over 1?
100 grams of aluminum.
Grams of aluminum on top. What am I going to put on the bottom of the next one?
For aluminum.
Okay. Not for aluminum, we're starting off with grams. We have to get to moles before we can use the number 4.
That's where you put the molar mass.
That's where we put the molar mass. It's going to go at the top of that line.
1 mole.
1 mole, because it's grams per mole. Grams aluminum cancels out. We have moles of aluminum on top now. We are right here in this corner with our plan. We need to go from moles to moles now. To go from moles of one to moles of another, we use coefficients. So what was the coefficient of aluminum?
4.
So I'm going to put 4 on the bottom. All right, we are going to oxygen. So what's the coefficient of that?
3.
So the moles of aluminum now cancel. So we have 100 divided by 26.9 times 3 divided by 4.
I got 2.788.
I will take that. Moles of oxygen is the unit we're left over with. So that's going to be our unit. I'm going to pause this and give you guys some time to think before and let you guide me through the next one, okay?
Okay.
I'm going to go ahead and resume. All right, so as I'm looking at this, my screen went blank. Stupid. Okay. So as I'm looking at this, where is my X going to go?
Under the AL.
How many grams of Al? So it's going to be an X. And since we're looking for grams this time, we're going to put grams. Where's that 200 grams going to go?
Under the 302.
Well, what is it 200 grams of?
Aluminum oxide, so under the 2AL.
There you go. So 200.0 grams goes here. Are we changing compounds?
No.
What information did they give us on? Where's our 200?
It's grams under the aluminum oxide.
Okay, what are they asking? Where's our X at?
Under the 4 aluminum.
Okay, so we are indeed changing compounds. So that means we're going to need that horizontal line. What word goes on top of that horizontal line?
On the coefficient.
Very good. We're basically just making sure we have a plan here. All right, what are the end caps of that word coefficient? What goes on either side?
Moles.
Mole.
Mole. All right, so now let's take a look at our numbers and X's. When we start at 200, what's the unit there?
Grams.
Grams. So we need to get from grams to moles before we can continue. Meaning we need to get the molar mass of aluminum oxide. We solved that in a previous problem. If we go back to number 1, I think.
It was 6. It was 101.8.
101.8. So that was 101.8 grams is equal to 1 mole. We got that off the periodic table. All right, so on the left-hand side is we have moles here. Is that what we're looking for?
Mm-mm.
What's the unit we're looking for?
Grams.
Grams. So we need to go from moles to grams here. So we have another one we're going to have to use a molar mass for because grams means molar mass. That's 26.9. This process just basically makes it so you have all your plan written out. It's like a blueprint for you to make sure you know what to do. Then from here, you follow the arrows. At the beginning of the arrows, what's the number that's going to go over 1?
The 200.
Good. All right, we have grams of Al2O3 on the top. What am I going to put on the bottom of the next one?
2Al2O3.
That's in moles. Coefficients are for moles to moles. We're not to that point yet. We're on this arrow right here. That means we're going to use that molar mass. So to go from grams to moles before we can use those coefficients. So if we have grams on top, what am I going to put on the bottom of the next one?
The 101.8.
There you go. What am I going to put on the top here? It's grams is equal to what?
1 mole.
Grams cancel. We are now here in our plan with moles of Al2O3. We're going to go from moles of one to moles of another using those coefficients. So what am I going to put on the bottom of the next one?
The coefficient of aluminum oxide.
Okay, so what is that?
2.
That's where that 2 comes in. We're going to aluminum. What's the coefficient of aluminum?
4.
So I'm going to put 4 moles on top. The Al2O3 now cancel. 4 moles of aluminum on top. What's the question actually asking? What unit?
It's asking
Grams. So now we need to go from moles to grams. How are we going to go from moles to grams? Whenever you see grams, what do you think? So we have this written out here in our plan. So if I have moles of Al on top, what am I going to put on the bottom of the next one?
Moles.
Mole. What number goes with moles?
The 1.
1. Very good. What am I going to put on the top?
The 26.9.
Absolutely. So that means the moles of Al cancel out. Is our last line saying what we're looking for? The last line says grams Al. Is that what we're looking for?
Yes.
Yeah.
Okay, so from here we calculate. 200 divided by 1.8 times 4 divided by 2 times 26.9.
I got 105.69.
That was as hard as it's going to get. That's pretty hard. Are you starting to see the step-by-step method, though?
Oh, I didn't hear you.
I asked if you're starting to see the step-by-step method.
Yeah, a little.
Do you want to do any more, or do you want to let your brain rest?
One more.
This is going to be an easier one. This is number 5. How many moles of carbon dioxide? What do I do?
You do the X grams.
What unit?
Do you do grams or moles?
Moles. The question is asking about moles. Where am I going to put that?
Under the carbon dioxide.
Or CO2. You see why it was important to remember how to name stuff? Will form in 5.5 moles C3H8. What am I going to do with that?
You're gonna put that under the C3H8 over 1.
Hey, what's mine in here?
Okay, we're going from moles of C3H8 to moles of CO2. We're changing compounds. As we're given information about C3H8, we're being asked about CO2. What word do I put above the arrow?
Coefficient.
What unit goes on either side of the horizontal arrow?
Mole.
Moles. Did they give us 5.5 in moles?
Mm-hmm.
Are they asking about CO2 in moles?
Yes.
So do I need more mass?
No.
No.
I don't need more mass in this one. You only need that if you see grams. So what's my first step in my equation?
Put 5.5 moles of C3H8 over 1.
Yeah. I have to write slow. Otherwise it doesn't register on my computer. Okay. I have moles of C3H8 on top. What do I do on the bottom of the next one?
C3H8 goes on the bottom.
Right, moles C3H8 go on the bottom. I'm right here in my plan on the left-hand side. What do I use to go from one compound to another?
Coefficients.
What's the coefficient of C3H8?
1.
1. It's the invisible 1. We're going to get to CO2, so that means I need the coefficient of that one. What do I do on top?
Put 3 moles of CO2.
That gets us here in our plan. Moles of C3H8 cancel out. So it's going to be 5.5 times 3 divided by 1.
I got 16.5.
I'm guessing I rounded this one up to 17 because of sig figs. There's only 2 here.
Do you want us rounding them up? Or
At this point, I want to see that you know how to do it. I'm not going to be nitpicky about sig figs. I'm more worried about you knowing the process. How do we feel, ladies?
It's okay.
I feel pretty good about it.
You feel pretty good. Ashayla, do you want to do more, or do you want to try it on your own for a little while and see if you need help later?
I'll try it on my own.
That sounds like a good plan. Let me cut this off then.